All right, today we've got a very exciting topic. We're going to learn how to do graphics output and sound output using Java. Thus far, our input has been entirely text-based, right? We've either gotten text input via command line arguments, or we've gotten text input from standard input, either from a file or interactively from the user. And all we could do was output text to the console using system.out.print and system.out.println. We can make some games, and so here's a screenshot of my zombie apocalypse game, and you can have somewhat interesting games. And if you were a gamer way back in the day, these are the sort of games you would have been playing, all in ASCII text. But it's not very exciting, is it? So let's learn how to do graphics and sound. We're going to use two support classes. So just like we're using the standard in class from the folks at Princeton, we're also going to use a StdDraw and a StdAudio class. These piggyback on functionality in the Java toolkit. So eventually, if you carry on as a Java programmer, you'll learn how to use graphics and audio yourself directly using the Java toolkit. But for now, for beginners, it's easier for us if we use these support libraries. So what StdDraw and StdAudio have are a bunch of static methods, things we can call that will draw various things, and we can do it quite easily. StdDraw does, these classes don't do everything, but they do enough to make some pretty interesting programs for an introductory class. You can draw images, you can draw simple shapes, you can color those shapes, you can get interactive real-time keyboard input, so you don't have to have this interaction where they type and hit return and type and hit return. You can have your game continue to play and detect whenever the user hits keys. StdAudio will play standard audio formats like WAV files, and as we'll perhaps see in a future assignment, you'll be able to actually generate your own audio samples and send them to StdAudio. Just like standard in, StdDraw is a separate class, and just like standard in order to make your program work, if you're using any StdDraw methods, you need to put the StdDraw.java file into your directory. So you can download StdDraw.java either from the Princeton book site, or you can download it from our course website. It's good at drawing simple things. You can draw rectangles and circles, lines, simple polygons, you can draw text, you can change the colors, and so on. You can draw images, so you can draw, if you download a JPEG or a PNG or a GIF image from the web, you can easily draw that, and so that's handy. You can make something that looks quite nice, like you can draw the Mars background just by downloading a Mars image and then calling a single command in StdDraw. We're also going to learn how to animate things. I'll show you, an example of making an image spin. You could do other stuff like making balls bounce around the screen. We'll also be doing some video game style programming assignments, and you'll need to know how to do the animation in order to do those games. Here is the Hello World for drawing. It's one line program, short and sweet. Hello Draw, it has one line, StdDraw.filled circle, and you call it with three parameters. This method filled circle is in the StdDraw library, so you have to prefix it with StdDraw and then call it with the X location, the Y location, and the radius. The first number says please put it 0.25 over on the X-axis, put it 0.5 up, so dead center, and then make it a radius of 0.25. And this is what you'll see, so let's run it in Eclipse. I have Hello Draw over here in my Eclipse. Maximize that. And notice I've got StdDraw in the same directory. Now if I were to take StdDraw out of this, it's going to complain, just like it did when we took standard in out of the Eclipse project. And if I look, we can actually go look in my directory here on my file system. Here we have the Hello Draw program, and you see there's StdDraw.java is in the same directory with it. You can run these graphic programs directly from Eclipse. Oops, I ran the wrong program there. I got to click on Hello Draw. That was the main program for StdDraw. Let's run the main program for this, and you see it opens up this window, the StdDraw window, automatically. And you'll notice your program continues to run until you close this window. So be sure to close these windows, otherwise, and nothing bad will happen, but you'll end up with 100 of these StdDraw windows on your computer. You can see the program's still running because we've got the red box down here in Eclipse. If we hit the X box, then the program actually has terminated. What are these numbers? Why did I use 0.25 and why did I use 0.5? By default, StdDraw has a coordinate system that's a unit box. The lower left is 0.0, 0.0, and then the upper right is 1.0, 1.0. Now we can change this, and I'll show you some commands you can use if you want to use a different coordinate system, but this is the default system. If you don't do anything differently, this is the coordinate system you're going to get. If we wanted it 1/4 over the center of this circle to be 1/4 of the way over on the x-axis. That's why I use 0.25, because that's 1.0 divided by 4, and I wanted it midpoint on the y-axis, so that was 0.5. Importantly, notice the lower left is 0.0, 0.0. So the coordinate system in StdDraw is just like the coordinate system you're used to in math, where you have the origin and x gets bigger as you go to the right and y gets bigger as you go up. This is, however, different. If you've done some programming before, this is different than how many programming interfaces have a coordinate system. So in a lot of other systems, the top left is 0, 0, and y gets bigger as you go down, but not in StdDraw. StdDraw has 0.0 on the lower left. It would be kind of boring if all we could do is draw circles, so we can draw other things. We can draw filled circles, but we can also draw normal circles. Normal circles are obviously just not filled in. So this center guy is the call to circle, where this big black guy is this first call to filled circle. You can draw rectangles. Notice rectangles have 4 parameters. So this is a common thing. Different methods have different numbers and types of parameters. If you ever call filled circle, you're going to need 3 parameters. If you ever call circle, you need 3 parameters. But if you call filled rectangle or rectangle, you need 4 parameters. And we'll talk about what those things are. Text has actually even a different look, right? It's got 3 parameters, but it has 2 double parameters, and it has a 3rd text parameter. Because obviously, if you want to draw text, you got to tell what kind of text. Text is telling it where the x is and where the y is, and then what the text is. And by default, what the StdDraw methods do is draw things at the center. So this is actually centering hello world on the point 0.7, 0.5. So the center of that string is at that coordinate. And the same for the filled rectangle and rectangle. The first 2 are the x and y. That tells you where the center of the rectangle is. And then these 2 parameters tell you half of the width and half of the height. Let's load my Draw Shapes program up. And then finally, I'm showing you another command here. I'm looping over 1,000 things, and I'm just drawing random points. So points are just a single pixel, a single point on the screen, and they just need an x and a y. Line is another primitive. You can give it an x and a y, and then a second x and a y, and then it connects them with a line. All these lines start in the center of the screen, and then they radiate out to some random point. We can run that, and you can see it's not instantaneous either, right? You could actually see. Let's run it again. It takes a little while to draw those 1,000 points, and then the 20 lines are pretty quick. But the 1,000 points takes a while. I mean, we could even make it bigger if we did 5,000 points and ran it. You can see it actually takes quite a while to draw all those little points. One nice thing about working in Eclipse is it provides help when you type the name of something, you actually get help. Notice it's trying to auto-complete rectangle, and you can actually see what the parameters are. The first is the x, the first is the y, and then if I don't know if it's width or half width, they've named their variables very appropriately, and you can tell that it is in fact half the width and half the height. So that's a handy thing to know. If you don't remember the parameters of some of these things, you can always go look. If you really want to know what StdDraw does, you can go double click on StdDraw and then have a look through the program. And there'll be a lot of things you might not understand right away in here, but if you go to look for something like filled rectangle, you'll see the Princeton folks have put a nice friendly comment describing what the method does, what the different parameters mean, and if something goes wrong, you can get this thing. Well, eventually, maybe not in this course, but you can handle different kinds of errors using something called an exception in Java. The world, of course, is not just black and white. We'd like to have some color in our world, and in StdDraw, how you do this is you set the pen color. And setting the pen color, think of StdDraw, it has a single pen in operation, and you can swap out what pen StdDraw is using. Once you swap it out, it will continue to use that color until you change it. If I set the color to red, it will draw this filled circle in red, and it will continue to draw things in red, but I switch to a blue color, and then I draw this circle in blue, then green and pink, and so on. All these points are going to be drawn in magenta because I've set the pen to magenta, and then I draw my 1,000 points. These all end up magenta, and then this set all end up gray. There are a bunch of standard colors. Eventually we'll learn how to make colors of whatever red, green, blue combination you'd like. But for now, you can just use some of these standard colors, and you get these by just typing StdDraw dot and then the name of the color. And again, if you can't remember what you can type, so you're going to do StdDraw dot set pen color. Okay, and then I know it's something in StdDraw dot, and I can actually see and scroll through all these and choose. I can see the different things I can call in StdDraw, but I can also see all the colors available, and I can put in one, whatever color I fancy. Let's run the color example. Here's the color example. And there we go. So remember to close our StdDraw window. And that's the output I just showed you. You don't have to use this unit box coordinate system. You can change this, and there's two calls in StdDraw that allow you to do this. Sometimes it's more convenient to use some other coordinate system. The two methods you want to use are set x scale and set y scale, and they take two parameters and they set the minimum and the maximum of that particular dimension. If you call set x scale and set y scale with 0.0 and 1.0, this is just the default, and it will draw the circle in the same spot. I've also drawn, notice I've also drawn a rectangle. I've drawn the rectangle centered at 0.5, 0.5 with a 0.5 half width and a 0.5 half height. But it didn't really go all the way to the edge, did it? So StdDraw has this little bit of a little bit of buffer margin space around the edge. So 0.0 is actually this point right here. All right, and 1.0 is actually up here. And if you draw, say, at 1.05, 1.05, you might actually see your point. You might still see the point. It'll just be up and to the right of the box here. The same program with a different x and y scale will actually look different. Here I've set the x and the y scale to be 0 to 2.0. So now 1.0, 1.0 is the middle of the screen, and 2.0, 2.0 is up in the top right. And this effectively shrinks the drawing to this quadrant in the lower left. If I go even further and set 0 to 30 and 0 to 30, then I get a really tiny little box and circle down there. And we'll be using these set X scale and set Y scale in some of our assignments. It's a convenience thing. You wouldn't have to do this, but often you can have StdDraw do some of the conversions. You can operate in sort of the coordinate system that makes more sense for your problem, and you can have StdDraw do the conversion itself rather than having to do it yourself. Let's draw some images. StdDraw supports a variety of different standard formats like JPEG or PNG files. You draw them using the picture method, and the picture method takes an X and a Y and then the file name. And if you just put the file name in here and no path or backslashes or forward slashes or anything like that, then it's going to look for that file in the same directory. Here's hello world for drawing a picture, StdDraw.picture. I give it the X and the Y, and in this simple program is going to try and draw whatever I specify as the first command line argument. And you can see in my project here I've placed a few things in the same directory. Like I said, it needs to be in the same directory, so I have a don't panic PNG file, and I also have a frog. And let's see what we have in our run configuration argument. Currently don't have anything, so let's put don't panic PNG as the first command line argument, and we'll run it. Whoops, same thing happened as before. We ran the old program. There we go. There's our draw image, and there you go. So very simple to draw images. So you can get very cool looking programs by just downloading a bunch of good graphics and drawing them. An important thing to point out about how this works is it draws this image centered on the point you give it. I asked for don't panic to be at 0.5, 0.5, and thus his center of his green blobbiness is right in the center. It doesn't do something like put it, if you're used to other, if you've done some programming before, sometimes these methods take the lower left or the upper left or one of the corners, but not in StdDraw. StdDraw centers it on whatever X and Y position you give it. And if we want to draw something different, we can just change it to a different, we can change it to the frog JPEG, run that program, and we'll see the center of this rectangular JPEG image is at 0.5, 0.5. Besides the coordinate system, there's also a window size. This StdDraw window defaults to being 512 pixels by 512 pixels. Here's a screenshot of my desktop, and I have a 1920 by 1080 monitor, and here's the StdDraw window taking up its 512 and 512 pixels. We can change that if we want in StdDraw. So StdDraw has a method called setCanvasSize, and setCanvasSize takes a width and a height, and these width and heights are in pixels. If I set 100 100, I get a very tiny window. I could do 100 200 and get kind of a a tall window or a wide window or whatever I want. Or I could set 1920 1080 if I want a gigantic StdDraw window. You normally call this just at the start of your program. Same with set X scale and set Y scale. You only need to call it once at the beginning of your program, and you don't need to call it repeatedly. If your window's at 1024 by 512, it'll stay there for the length of your StdDraw program. Another thing we'll be doing with StdDraw is animating things. You can draw stuff, but you can also erase stuff. And you can also use StdDraw to insert a pause in your program. Here's the basics of creating an animation loop. First thing you usually want to do is clear the screen. And there's a call in StdDraw called StdDraw.clear, and that just blanks everything out, makes, pastes white over the whole window. Alternatively, if you've got like a background image that occupies the whole screen, like a Mars background or something like that, you can just do StdDraw.picture in the center of the screen, and that will also effectively erase anything else. You draw whatever new stuff you want, then you need to sleep for a while. This is important. Computers these days, they're pretty dang fast. And so if you don't sleep for a while, the animation is going to go really super fast. The way you kind of chill out for a bit is to call StdDraw.show, and it takes a parameter which is how long to pause in milliseconds. So 1,000 would be a 1 second pause, 100 would be a tenth of a second, and so on. Here's an example program called Spinning Image. It turns out picture, now before we were calling picture with just the X and the Y and the image, but notice I've added a fourth parameter here. And it turns out in Java some methods can have multiple forms, and this is the case with picture. Picture can draw itself centered at a certain location, but it can also draw itself at a certain rotation, where we specify that rotation in degrees. We're going to clear it out. We're going to draw the picture. This line, degrees equals degree plus 1% with 360, adds 1 degree to the rotation. And then this is kind of a computer science cleverness way of keeping that bounded. So degrees is going to increment each time through this loop, and it'll go from 0 to 1 to 2 and eventually reach 359, and then it'll go to 360. But the modulo of 360, so 360 modulo 360 is 0, and 361 modulo 360 is 1, and so that essentially causes it to cycle around. Let's try Spinning Image. Here's the same program in Eclipse. Run configurations, arguments. Let's do don't panic. Oops. Gotta set the right project. Alright, so that one's also set there. And there he goes. He's spinning around. Let's see what else we could do this. What happens, what happens if we don't call this clear command? The loop's still going to run, and every iteration of loop it's going to draw the picture at a new rotation angle. The problem is, whoa, you could argue that maybe looks a little cooler, a little psychedelic, but as he rotates, he's leaving a trail behind him. That's typical what you're going to see if you forget your clear command. Let's say we forget the pause and we just run as fast as we can. It'll still work. Whoa. Okay, can you even see that? There's kind of don't panic, but he's going so fast it's causing all kinds of flashing and things we don't really want. We can modify this. If we want him to go slower, we could put 100 in there, so a tenth of a second. Now he rotates very slowly. Or we could use a single second, in which case he rotates quite quickly. Another thing we might want to do with StdDraw is detect keyboard input, different from how we use standard in. So standard in is good if you've got very regimented input. You prompt for something, they type it in, and then they hit return. You ask for something else, they type it in, and you hit return. StdDraw is better when you want to make some sort of game or a program that has to respond to real-time keyboard input, a letter at a time. There are two main methods we're going to need for this. Has next key typed. Whenever you call this, it will return true if there's a key waiting. And if there's a key waiting, then you can go ahead and call StdDraw.nextKeyTyped, and this will return a character variable containing that key. It's important though, you must call hasNextKeyTyped before you call nextKeyTyped. Otherwise, your program is going to crash. Also, pay attention, this keyboard input only works when the StdDraw window has focus. You'll need to click on the window with your mouse. If the window doesn't have focus, you'll hit your keys, but they won't get captured by StdDraw. I'm going to modify my spinning image now, And I'm going to make it spin clockwise when they hit the letter A, counterclockwise when they hit the letter S, and then if they hit some other key, I'll just make him stop rotating. Here's the program that does that. I still have my degrees variable. I've added a new variable called direction, and direction is going to control whether he's currently stopped, whether he's moving clockwise or whether he's moving counterclockwise. Notice I've tested, is there a key available? And if there's a key available, then I go ahead and I pull the key from StdDraw. It's a char variable. It can contain a single character. And I can compare that single character with the equal operator to whether it's the A letter, the S letter, or is it something else. Notice I'm using single apostrophes because we're talking about a char variable here and not a string variable. We use double quotes for strings. We use single apostrophes for char variables. Depending on the direction, all right, I'm able to just update my degrees by either adding 1 or adding -1, that is subtracting 1, or adding 0, in which case it doesn't spin at all. Here's that program in Eclipse. He starts out stopped. I hit the A key, he goes that way. I hit the S key, he goes that way. Spacebar. And that's how it goes. Notice if I were to lose focus, I'm hitting A and S right now, but it's not doing anything. That's because the window doesn't have focus. And now he'll do something. Final thing I'm going to talk about today, and it's really simple, is we may want to play audio. StdAudio provides a bunch of different methods to do various things. The simplest thing you can do with StdAudio is just play a audio file. And as long as that audio file is in a standard format like WAV or AU or MIDI or something like that, it will play that file. You just give it a single parameter, which is the file name you want to play, and then it plays it. What I've done with this program is I've just added a single line. It now takes 2 command line parameters. args1 is the second one, and it will play that when you start the program up. And to make sure I'm on the right project, I could use my frog.jpg as the image and frog.wave is my file. And if I run this, all right, hopefully you could hear that. You can hear the frog ribbit at the beginning. He only does it once here. If we were to move that, this is probably a bad idea. Let's see what happens. This is going to play it every 10 milliseconds. I don't know if this is a good idea. Hey. Okay. That's probably not a good idea. So you don't want to play audio too often. Let's put it back to where it was, and we'll just play it once when it starts. Or you could do something like, I could change this so it plays only when they, for example, stop. And I could do that by creating a code block here. Remember, if you have more than one statement in if or else condition, you need to bracket with curly braces. I can make him spin, and whenever I hit a button, he ribbits. Anything that's not A or S. If you want more information about either of these classes, you can either just go look at the StdDraw Java file or the StdAudio.java file, or there's also online documentation on Princeton's site. You can see there's a whole load of different things you can do with StdDraw. These are just some of them. You can draw polygons and filled polygons and change the font and a bunch of other things. To summarize, we learned today how to use 2 support libraries or 2 support classes, StdDraw and StdAudio. They provide a very easy way for us to start programming using graphics and sound. We also learned how to do an animation using StdDraw by creating a loop and then having the loop clear the screen, draw the image, sleep for a little bit using .show, and then looping around. And another important bit we learned is how to use keyboard input. We can interactively get keyboard input and make our programs responsive to those key presses.